Okay, everybody, I have up here two trinomial expressions. If you notice, both of them do not have a leading coefficient of 1. Let's look at their leading coefficient. Well, this starts out with -1. Well, that's not a positive one, so that clearly tells me there's an issue here. This is a trinomial. It is in the correct descending order, but it's not starting out with a leading coefficient of +1. Therefore, the first rule you should try is the GCF rule. See if there's a term, a number, or a variable that you can divide all of these by to get a 1. Well, that's easy. What can you divide -1 by that will make it a +1? Very good. You would divide it by itself, -1. And if I factor out the GCF a -1 from the first term, I have to factor out a -1 from all the terms. So the first thing to understand is, sweethearts, if your trinomial starts out with -1, you cannot automatically break into two parentheses. You have to factor out that -1 by doing the GCF rule and telling me what's left. When we divide each term by a -1, we know it just changes the sign. So that would make my x squared now positive, my 2x would become negative, my 15 would become negative. Now I still have a trinomial, but now my trinomial starts out with a leading coefficient of +1. And that fits the pattern that I know that I now can keep factoring. So now I can use the trinomial rule and break this into two sets of parentheses. It is FOIL, first, outer, inner, last. Okay? Now it's easy. What multiplies to x squared? Well, x times x is my only option. My last term is 15. That could be 1 and 15 or 3 and 5. Do I want to add or subtract? I want to subtract to make what's in the middle, which is 2. 1 and 15 will subtract to 14. Doesn't work. 3 and 5 will subtract to 2. That works. I want to subtract, which means the signs have to be different. I want to subtract to make a -2. So then the sign in the middle goes to the larger, the 5. The 3 gets a positive. But this isn't your final answer, because remember, when you factor, you should be able to check by multiplication. If I multiply right now, x times x is x squared, and I have up here a -x squared. What you got to remember is that GCF you pulled out comes down in front. This is your factored form. All of this would multiply back to the original. Because check it, x times x would be x squared, and x squared times -1 would be -x squared. Outers, x times -5 is -5x. Inners, 3 times x is +3x. A -5x and a +3x would be a -2x, but times that by a -1, you'd get a +2x. Last, 3 times -5 is -15, but that times a -1 would be +15. All right, let's look at our last expression here. This is a trinomial. It has 3 terms. Now you're going to say, but Ms. Black, it has a leading coefficient of 1. It does, but it's not our typical trinomial. If you looked at every example I have modeled for you for factoring trinomials, every expression starts out with a squared, b squared, x squared, y squared. This starts out p cubed. So again, it doesn't follow our pattern. Our pattern has to be, when we factor a trinomial, it has to have a leading coefficient of 1, and it's got to have something squared. So we have to first look for the GCF. The GCF here is p. We can divide each of these terms by the letter p. So we put the p in front, and we tell me what's left. One set of parentheses. P cubed divided by p is p squared. Negative 10p squared divided by p is negative 10p. 24p divided by p is positive 24. Now if you look inside, I still have 3 terms, trinomial, but this is in correct order. The leading coefficient is 1, and we have a p squared. So this is doing backwards FOIL. So I'll put my 2 sets of parentheses. First term, the only thing that can multiply to p squared is p times p. Last term, oh my, it's 24. Many options. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Let's read. I want to multiply to 24 and add to 10. 1 and 24 adds to 25. 2 and 12 adds to 14. 3 and 8 adds to 11. 4 and 6 adds to 10. Great. I want to add. The signs must be the same. I want to add to a negative 10. They both must be negative. This is not the final answer because you factored out that p in the beginning. Do not forget to bring your GCF down. This is your factored form. If you were going to check it by multiplying, p times p is p squared, and p squared times another p would be p cubed, and etc. So remember, when we're factoring trinomials, the first rule is look for what they have in common, the GCF, and pull it out. If your trinomial doesn't start out with a 1x squared or a 1a squared, there's probably a GCF you need to take out. One more rule to go. I'll see you later.